Welcome, aspiring ethical hackers and cybersecurity enthusiasts. Today, we're delving into a topic that's both intriguing and vital in the realm of cybersecurity: exploiting Android devices remotely. Remember, this video is strictly for educational purposes, and we do not endorse any malicious activities. Our mission is to equip you with the knowledge to identify vulnerabilities, to strengthen your own or your organization's security posture, and to contribute to safer digital spaces. We'll be walking you through the entire process step by step, ensuring you understand the principles, tools, and techniques involved. We'll start by setting up our environment using Kali Linux and Metasploit, then move on to choosing, setting up, and executing the exploit, and finally, we'll discuss what to do post-exploitation. So grab your notebooks and let's dive into the fascinating world of penetration testing. Welcome to the first step, setting up the environment. The tools of the trade are crucial, aren't they? We're going to kick off our journey into the world of Android device exploitation by setting up our hacking environment. We'll be harnessing the power of Kali Linux, a favorite among ethical hackers worldwide, thanks to its plethora of pre-installed tools designed for penetration testing. But our arsenal would be incomplete without Metasploit. This potent platform allows us to craft and execute exploit code against a remote target, making it an indispensable tool in our toolkit. Now let's dive into action. We need to ensure our Kali Linux repositories are up to date. Once that's done, we'll move on to installing Metasploit. Remember, a well-prepared environment is the foundation of successful penetration testing. With Kali Linux updated and Metasploit installed, we're ready to move to the next phase. Now, we're on to the second step, choosing the exploit. It's time to decide which vulnerability we'll target. The Android Debug Bridge, commonly referred to as ADB, is a service that provides a wealth of functionality. It's a veritable goldmine for those looking to explore the depths of an Android device. However, this service is often left open on devices, making them an attractive target for remote exploitation. It's like leaving your front door wide open while you're out of town. Not a wise move. The ADB exploit is a known vulnerability that we'll be using for this demonstration. But how do we find it? Metasploit is a treasure trove of exploits, and finding the right one is as simple as querying its database. Let me show you how to find and select the ADB exploit in Metasploit. With the exploit chosen, we're all set to configure it. Our third step involves setting up the exploit. Getting the details right is key here. So, what exactly does this entail? Well, we need to configure the payload, set an IP target, and select a port. Let's break this down. First up, configuring the payload. This is the code that will run on the target device once the exploit is successful. You'll need to select a payload that matches your intended outcome, whether that's gaining shell access or installing a backdoor. Next, we set the target IP. This is the Internet Protocol address of the device you're aiming to exploit. Without this, there's no way to direct your exploit to the right place. Lastly, we choose a port. This is the digital door through which our exploit will enter the target device. Remember, precision is crucial in this step. One misstep could mean the difference between success and failure. All set with the exploit. It's time to put it into action. Step 4, the exciting part, exploiting the device. Let the games begin. With our environment all set, exploit chosen, and everything well configured, it's time to run our exploit. This is where the rubber meets the road. We'll execute the exploit in Metasploit, targeting the device's IP address and port we've previously determined. If our exploit is successful, we should gain remote access to the device. Think of it as a kind of digital handshake, where we reach out and the device reaches back, granting us access. Once we're in, we'll have the ability to interact with the device remotely. It's a bit like having the keys to a digital kingdom, but remember, with great power comes great responsibility. We're doing this to find vulnerabilities, not to cause harm. We're in. Now what can we do with this access? Our final step, post-exploitation, is where we make the most of our access. This is the stage where we truly utilize the access we've obtained. It's akin to a thief entering a vault. Now that he's in, what does he do? Well, he can start by dumping data. This involves extracting sensitive information from the device. We could be talking about anything from contact lists to photos or even saved passwords. Next, installing additional payloads. This could include scripts that allow us to maintain our access or even escalate our privileges. But perhaps the holy grail of post-exploitation is gaining root access. This is the ultimate level of control, allowing us to do just about anything on the device. However, remember, with great power comes great responsibility. This knowledge is to be used ethically with permission. And that, dear hackers, is how you exploit an Android device remotely. Now that we've exploited the device and accomplished our goals, it's time to move on to the next critical stage. Scene 7 is all about ensuring a traceless exit. Leaving no evidence of our activities is just as important as the exploitation itself. This is a crucial aspect of ethical hacking, as it ensures we don't leave any vulnerabilities open that could be misused by malicious hackers later on. First, we'll need to clean up any logs or history that may have recorded our activities on the device. This can be done using various tools and commands that overwrite or delete these records. Be meticulous in this step. Every command you executed, every file you accessed or altered, must be accounted for. Next, we'll uninstall any additional payloads or scripts we installed during the post-exploitation phase. This step ensures we leave the system just as we found it, minimizing any potential disruptions to the user. Lastly, we'll close any connections we've established with the device. This is critical to ensure we don't leave any backdoors open which could be exploited by others. Remember, the goal of ethical hacking isn't just to identify and exploit vulnerabilities, but also to ensure the overall security of the system. Leaving no trace behind is a part of that responsibility. So be careful, be thorough, and always leave a system as secure as you found it, if not more so. Well, we've come to the end of our tutorial, but remember, with great power comes great responsibility. Penetration testing and ethical hacking are powerful tools in our digital world. Tools that, when harnessed correctly, can help identify vulnerabilities and improve security measures. This knowledge is not meant to be used maliciously, but rather as a force for good, to safeguard our digital spaces and protect against potential threats. The techniques demonstrated in this tutorial should only be applied to devices you have explicit permission to test. Unauthorized access or exploitation of devices is not only unethical, but also illegal. As ethical hackers, our role is to use our skills to contribute to a safer, more secure cyber environment. So, as you venture forth, remember the hacker's code. Respect privacy, protect systems, and above all, use your power wisely. Thank you for tuning in. Until next time, happy ethical hacking.